Consider this problem. A mass of flywheel of an engine is 6.5 tons and the radius of gyration is 1.8 meters. The mass of flywheel is given here. Mass of flywheel is 6.5 tons, which can be written as 6500 kg in 1 ton, that is 1000 kg. And the radius of gyration small k is equals to 1.8 meters. It is found from the turning moment diagram that the fluctuation of energy is 56 kilonewton meter. So the fluctuation of energy, that is delta E, is given 56 into 10 raised to 3 Newton into meter. I converted this kilo is 10 raised to 3. Okay. The mean speed of the engine is 120 rpm. So small and capital N is 120 rpm. You can use any of the relation above to determine the maximum and minimum speeds of the flag. Now we know that if Nmax and Nmin are the maximum and minimum speeds of the flywheel, and we can determine that delta E in terms of rpm speed is pi square by 900 mk square cs mk square cs into n, that is mean speed. From using this relation we can find cs, the coefficient of fluctuation of speed, or you can write cs as 2 nmax minus nmin by n. So pi square by 900 m k square, the value of cs is nmax minus nmin by n. So n cancel out, you get this delta E. If I substitute the value of delta E here, which is 56 into 10 raised to 3, and this is pi square by 900, the value of m here as 6500. The radius of gyration is 1.8 square, and I don't know the value of nmax minus nmin. The value of nmax minus nmin after calculations can get nmax minus nmin is equals to 2 rpm. The calculations and first relation. Also, you know that mean speed of the engine, that is nmax plus nmin by 2 is equals to 120 rpm. This is the second relation. By solving these two relations, you get the value of nmax and nmin. The value of nmax is 121 rpm and nmin is 119. It's very simple to solve these two linear equations. Here nmax plus nmin divided by 2 is 120. So nmax plus nmin is equals to 240. If you add these two values, so the total value is 240 plus 2, that is 242 2 n max equals to 242. So n max equals to 242 divided by 2, which is equal to 121. And if I subtract the value of 2 from 121, I get value of minimum. Okay, this definitely mean of these two values is 120 given in the problem. So these are the final answer of the questions. Okay. Now consider this next problem on the flywheel. A flywheel of a steam engine has a radius of gyration is 1 meter and mass of 2,500 kg. So the mass of flywheel is 2500 kg and the radius of gyration is 1 meter. So you can easily determine the mass moment of inertia of the flywheel, which is mk square. So 2500 kg meter square. The starting torque of the engine at the time of the starting T equals to 1500 Newton meter and maybe assume as constant. So the starting torque remains constant. Determine the angular acceleration of the flywheel and the kinetic energy of the flywheel after 10 seconds. So first we are solving for problem 1. Let alpha is angular acceleration and we know that the starting torque is equals to I into alpha. Simply the alpha is equals to torque 1500 by I 2500 is equals to 0.6 radians per second square. Your first answer, which is a very simple mechanics problem. And the kinetic energy of the flywheel after 10 seconds from the start. So that the flywheel's speed at rest is 0 because it is starting, and if it's starting from the rest position, so the initial angular velocity of flywheel or initial speed of flywheel is should be 0. The initial speed of flywheel omega, the initial is 1 is 0, and after 10 seconds the omega 2 the speed or angular speed after 10 seconds. So final speed is equals to initial speed plus acceleration into time. So 0 plus 0.6 into after 10 seconds, it is 6 radians per second square. In this way, I can determine the speed of flywheel or angular speed of flywheel after 10 seconds and the kinetic energy of flywheel after 10 seconds based on this speed 1 by 2 omega square into I, omega 2 square into I. So it is 1 by 2 I 2500 into omega 2, that is 6 square, 36 by 2, 18, 45 kilonewton meter or 45 kilojoules of energy is available after 10 seconds at the flywheel. So this is also a simple example. based on the flywheel.